Hi and welcome to challenge number 14, filter even numbers. In this challenge, our task is to return a new array of only even numbers. So if we have an array like this, where we have 1, 2, 3, 4, 5, 6, our task is to return this output, 2, 4, 6, just the even numbers. And for this specific challenge, we're not going to talk about too many edge cases because at this point, we have already done 3 challenges comprehensively when talking about arrays that contain numbers, arrays that contain strings, and arrays that contain mixed data types. So in this challenge, for all 5 languages, my aim is to just implement as if I were to get an array that only contains numbers. So I'm just going to produce numbers. And these numbers are just going to be integers. So we're just going to have like this one array that we're going to test. So the first language that we're going to get started with is going to be JavaScript. And let's go ahead and let's create a function. I could call this filter even numbers. What this function is going to receive is going to be an array of numbers. And what we produce is also going to be an array of numbers. So how do we go about this? Well, we could, since this is an array of numbers, we could call a filter method on our numbers. So I could say numbers.filter, and I can filter numbers based on their divisibility. So if a number is divided by 2 and the remainder of the division is 0, that means that number is even. That's pretty simple, right? But if there is some sort of a remainder, then we don't have an even number. That's an odd number. And this divisibility, we can use the modulo operator in JavaScript, which is like one of the very basic things you learn once you get started with learning JavaScript. So this function is going to have a parameter that is going to be called num, and we're going to filter these array items one by one. If any of the array items is divided by 2 and the remainder is equal to 0, then we return that from the function. There we go. And what filter method is going to do is it's going to create a new array and it's going to take a look at our input. So it's going to say 1 divided by 2, remainder is not going to be 0. 2 divided by 2, remainder is 0. So in that newly created array, it's just going to put 2, and then it's going to proceed in the same manner. I'm going to come right here. I'm going to say const input. This is going to be our input, and const output. Let's call our function filter even numbers, and I'm going to pass an input. And finally, let's log our output. Simple, right? I'm going to say note. First, I need to cd 014 tab, enter. Let's bring this window a little bit down. There we go. So here I could say node a tab, hit enter. There we go. So we got 2, 4, 6. Because if I divide 2 or 4 or 6 by 2, the remainder is going to be 0. But you need to keep this in mind that filter creates an array and it does this logic of division on any individual item of this array once. So it does it one time on 1, and then 2, and then 3, 4, 5, and 6, and that's it. And then we return that from the function. So it's a pretty simple solution for this one. Now we are going to get started with the TypeScript solution. For the TypeScript one, much like our previous challenges, we're going to go ahead and we're going to try to implement this manually. And for this one, what I'm going to use is the algorithm that I have in mind is a very simple one. It's called a linear search algorithm. And we're going to use array filtering as well. So I am going to try to make this solution as manual as possible. We're going to create a function that's going to be called filter even numbers, or nums for short. This is going to accept numbers parameter, and this numbers parameter, it has a type that is an array, but the array can only contain numbers. As I said, we want to keep this simple. So what do we want to do here? Well, we want to create a new array and we want to put all of the items in there. And since we don't use the filter method that creates a new array automatically, let's create a new array manually. I'm going to call this even nums, and the type of this is going to be an array whose items can only be numbers. But since at this point I don't have any numbers, I'm just going to initialize this with an empty array. Now I'm going to create another variable, and that is going to have the job of tracking our index. We want to make sure that we can move from the start of the array all the way to the end of the array, and so we do not go out of the bound. And the job of this variable, this even index, is to actually track the next available index inside of our array. So this index is going to start from 0. So I'm just going to say 0 here. Now, this part is going to be our linear search algorithm with array filtering. So we're going to have, since we want to do this manually, of course, we're going to use a for loop. We're going to get started with I. I is going to start from 0. Why? Because indices start from 0. But since indices are 1 less than the length, I can only go for as long or as much as, or I should say as long as 1 less than the length of the array. Because if length is 5, or in this scenario, length is 6, the maximum index is 5. So 5 is 1 less than 6. That's why we say I is 1 less than the length. And then we need to increment I in order to go to our next iteration. All right. So what do I want to do here? Well, I need to grab in every individual item from my array. Let me just jump into the JavaScript solution, copy these 3 lines, and I'm going to come down here and I'm just going to put them here. So what do I want to do here? I want to store 1 and then check it if it is divisible by 2. If it is divisible by 2, I'm going to push it to my even nums array. Okay, so I need to store it somewhere in order to do this operation, right? And then I am going to store 2. That's going to be the next iteration of the for loop. And I'm going to do the same thing, right? So it's the same filter method, but we just prolong it and overcomplicate it with this algorithm. So I could, and you need to keep this in mind that you could store these values inside of a variable and keep reusing that variable, or you could just say, okay, these values, they are stored inside of here. They're technically inside of the numbers array, and when I put an I inside of the square brackets, that's gonna select one item from the array in each iteration, in each time this loop runs. But since I don't want this to be confusing, I'm going to store this inside of a variable, and I'm going to call it current number. There we go. So in the start of the iteration, what is our current number? Current number is 1, so keep that in mind. We're going to say if our current number, which is 1, divided by 2 produces a remainder of 0, then that means it is an even number. Okay, so does 1 do this? No. So we don't go inside of the if statement. We go to the next loop iteration. In next loop iteration, our current number is 2. 2 divided by 2, remainder is 0, right? So we go inside of the if statement. All right. What do we do once we are inside of the if statement? Well, it's simple. We want to push these numbers to our even nums array. We want to put all these numbers that are divisible by 2 inside of that array. How do we do that? We could use the push method of arrays, but I want this to be manual. So instead of using the push method, we are going to do this manually as well. So I'm going to select my even nums array, and depending on which index it is, how do I find out which index should I put this specific number in? Let's say 1 is not going to come inside of this if statement. 2 is going to jump inside of the if statement because it's going to satisfy the condition. But then 2, at what position should I put 2 inside of the even numbers array? At what position? I don't know. That's why I created this even index. This even index is going to specify at which position I'm going to put my even, that's why it's called even index, that even number. And what is that even number? Well, that is the even sorry, that is the current number right there. We don't have any even number. And then we are going to increment our even index by 1. And why did we do this? Well, in the first iteration, we know what happens. So let's move on from that. In the second iteration, we got this number 2, which satisfies this condition. Therefore, we run this line, and this line puts this number 2 inside of this array. Okay, so number 2 holds the initial position inside of the even numbers array. Which index is that position? That's index 0. All right. We go to the next iteration, we get number 3. Number 3 does not satisfy this condition. We break out of this loop. We go to the next iteration. We get number 4. Number 4 satisfies this condition, right? So we put it inside of this numbers, this even numbers. But if we didn't have this even index, we would have replaced 2 with 4. So in each iteration, we would keep updating our even numbers, but there will always be just one number at a time. That's why we created this even index, so we can actually track at which index has been already occupied, so we can generate a new index. How do we generate a new index? We say plus plus. So index 0 has been occupied by 2. Once I say plus plus, that's going to create even index 1. And then even index 1 has been occupied by 4. So now this even nums array, it has 2 items at indices 0 and 1, which are 2 and 4. And the same goes for 6. Because since I'm inside of this if statement, I am going to increment that even index by 1. And what was the previous value? That was 1. 1 plus 1, that's 2. So 6 is going to occupy the position at the index 2. So now we have index 0, 1, 2. That means item 1, 2. That means items 2, 4, and 6. Basically 3 items. All right. So this is how this actually works. Now we need to return something from this function so we can actually produce. And we're gonna, what do we return? Well, we return our even nums or even numbers array. And that's it. Let me say TSC B tab, hit enter. There we go. Node B tab, make sure it is b.js. Whoops, that's a typo. Node, hit enter, and there we go. We got 2, 4, and 6. All right, TypeScript solution has also been completed, and we are going to jump into the Python solution. Now for Python, I thought of actually solving this like JavaScript version, but then that was really, really simple. So what I thought was, what if I go about this in a few different ways? So in Python, you might come up with even more ways to solve this using Python, but I'm going to give you 3 ways. So the first one is going to be using a list comprehension, which is the recommended way and which is the Pythonic way of doing it. So we have this def, which is a function. I'm going to call this filter even. I keep writing event even numbers, and I'm going to say this is v1. Now this function, we know it's going to receive an array of numbers. That far is known. Now how do you create a list comprehension? Well, the first thing you need to provide is you need to write the syntax for a list. That is square brackets. And then this list comprehension, since I want everything to be inside of here, this is bound to contain some sort of a condition, right? Depending on that condition, we are going to populate the same list, which is on line 2. So on line 2, we create a list, an empty list. We create a condition. Based on that condition, we populate that list. But how do we actually populate it? Well, we use a for loop as well. So we have a for loop, a condition, a creation of a list, all of that inside of these square brackets. So let's go one by one. There is no order to it. You could just go whichever way is possible. You could come up with a for loop and then with the if statement, but I'm gonna start from the end. So I'm just gonna write the if statement first. Now I'm gonna use num, and I need to make sure that I'm consistent when I'm using num. Num is gonna represent one item per one iteration, which is from my numbers array. So my numbers array, it contains however many items. I'm going to select one of that, check it against this condition, then I'm going to select another one. So one item per one iteration. So how do I check? Well, we could use the modulo operator here as well. We're going to say if this num divided by 2 produces a remainder of 0, that means it's an even number. Now, since we want this to be done for all array items, we need to have some sort of a repetition syntax, right? And that is going to be for num in, where is our array? That is numbers. But we still need that variable in order to, this is num, see? All of these have to be the same thing. So this num, we take a look at num inside of our numbers. If num divided by 2 produces a remainder of 0. That's it. So that is solution number 1. We're going to test all solutions in one go. So let's jump into the second solution. The second solution, we could make this look like exactly like the JavaScript solution using a filter method and an anonymous function, which is in Python, they're called lambda functions. I could do that as well. So let's say filter even numbers v2. What the function accepts remains the same, but how the function proceeds, that's going to be different. So we're going to say filter. Within the filter, we have the logic that is going to iterate over our array or list and do one thing per one array item, one specific logic. And it's going to keep repeating that logic for however many items there are within our array. But at the end of the day, we want this filter method to generate a list for us. That's why I'm going to wrap it around a list, and that's what we are going to return from the function as well. Cool. Now in JavaScript, filter method produced an array. In here, we just convert that into an array. So what is the logic? Well, the logic itself is simple, right? We say num divided by 2. If the remainder is 0, then we know that that's an even number. But then you need to pass in which array it is that you're targeting. That's the numbers array. But there is something else that you need to pass in here as well. This is a function parameter. Well, you need to specify your parameter, then you're allowed to use it inside of the function body. So here, we're using the function body without defining our parameter. We're using this num inside of the function body, but we have not actually defined this num. So let's go ahead and let's define it. And since this is a lambda function, we need to write the keyword lambda. You could think of this keyword as the fat arrow that we have in JavaScript for arrow functions. And this is our parameter, and that's it. So here are 2 of the solutions. For the third one, I am going to actually try to separate this logic. So we're going to have 2 different functions. One of the functions is going to filter. Another function is going to do the remainder part. You could do that as well. So I'm going to say is even. Now, this function is going to take a look at one number at a time. It's not going to accept an array. It's going to take a look at one number, and it's going to check if that number divided by 2 produces a remainder of 0. Whoops. That's it. So we're going to say, so we separate the logic, we keep everything simple, but we end up with a couple of functions instead of one. All right, so here we're going to say num divided by 2 produces a remainder of 0. So this is that logic that checks if one number is an even number. But then I need this logic to be repeated for all of my array items. Well, I still need to have my filter method, right? So I define a new function and I call it filter even numbers version 3. This accepts an array, and what does it do? Well, it creates a list by filtering an array. What is our array? Well, our array is the numbers array. But then where is the function body? Where is the logic that's going to calculate what should go inside of this new list that we're trying to create? Well, that's the is even function. There we go. So instead of doing this lambda function anonymous, we extract all of this, put it inside of a new function, and then in each iteration, we call that new function, right? And that's going to be what we return from this function as well. So let's do our test cases. We have our input, which is, I could just copy paste it, right? Instead of typing it. This is our input. We have output 1. That is going to be our filter v1, and I'm going to pass in this input. And then we have output 2 and output 3. So let me just fix that very quickly. And there we go. So we have 3 outputs, and we're going to have 3 print statements as well. The first one was list comprehension, right? That's going to be our output 1. Output 2 was filter with lambda, lambda. And the third one was filter with function. That's output 3. There we go. Let's save this. Let's try to get out of here. I'm going to create a new terminal, and I'm going to say Python C tab. Oh, we need to go to this directory first, and then I need to bring this up a little bit. There we go. So we have Python C tab, enter. There we go. So list comprehension produces 246, filter with lambda 246, filter with function also 246. Next up, let's go to our Go version, Go file, to create the Go version of the solution. For this Go version, what I want to do is actually go through 2 different ways, and let's just get started. So the first thing that I need to do is import our main package. There we go. We're going to create a func that we're going to call filter even numbers v1. There we go. Now, this is going to accept an array of numbers, but since I said we need to make sure that this is just numbers, we're going to say, okay, the type of this is integer, but what the function produces is also an array of numbers. Very good. So what do we want to do here? Now, we have an input slice or array or list, and we want to generate a new array and populate that new array with all the even numbers. All right, so a new array. Let's create a new array. I'm going to call this even numbers this time. The type of this is going to be integer. Now, in the first version of the solution, I want to do this sort of like how I did it in TypeScript, but I want to use some sort of a method to push elements to this even numbers. I don't want to do that part manual. So we need to have our looping syntax. The first thing that this for loop is going to give us, that's going to be the index, which I don't care. The second thing is the number. Now in here, I don't care about which index it is because I'm not actually considering that. I get started from the start of the array and I go to the end of that array, and that's it. And I keep checking each individual item. So I have this number using short variable declaration. We're going to grab our range, which is going to be the thing that actually iterates. There we go. So what do we want to do when we iterate over numbers? Well, in each iteration, we got index, which we ignored, and we got num, which is that array item. So if that array item is divided by 2, and we end up with a 0 remainder, that means that was an even number, right? And if it is an even number, what do I want to do? Well, I grab my even numbers and I say, okay, append that value. append to the even numbers that specific item of the array. And that's it. Well, if it is not an even number, like it's 1, 3, and 5, the loop condition, the if statement condition is not going to be satisfied. Therefore, we're not going to run this line number 8, this one. We're not going to run it. We're just going to run it for numbers that are divisible by 2. And finally, we need to return something from this function. That's going to be even numbers. And there we go. So this is the solution for the first way of going about this. The second way of going about this is as follows. We're going to use something that's called a make method. The make method allows us to pre-allocate the array's capacity, the slice's capacity. And what do I mean by that? So let's just get started with it. This is going to accept numbers as well with a type of int. And that's exactly what the function is going to return as well. So what do I want to do within this function? Well, I still need to create my even numbers array. And I'm going to use short variable declaration to initialize it. But we're going to use the make method. Why? Because we want to make everything complicated, right? So the type of the array that this make method is going to create is going to be of type integer. The initial capacity for this is going to be 0, which basically means that the initial length of this even numbers array is going to be 0. But if this is the initial length of this array, what is going to be the maximum capacity that this array could achieve? Well, it depends on the numbers array. If numbers array has like 100 items, let's say 50 of them are even numbers, so a maximum, it could contain 50 items, right? But then that could be variable. I could say half of the length of the numbers array. But then that could be also problematic, because what if we have like 100 numbers and 70 of them are even numbers? Like, it's not very clear for us to actually understand how many items are even within the numbers array, because we have not actually done that calculation. We have not done the division to understand how many items are there. But we could assume that all of the numbers inside of the numbers array, they are even numbers. So the number of even items within the numbers array is never going to go outside or above the numbers length itself. So if the numbers array has 10 items and all 10 are even numbers, so that's like 10 numbers. It's never going to be 11 numbers, 12 numbers, because that's going to be beyond the length of the actual numbers array. So we're going to say the upper bound of this new even numbers array or slice that we want to create with a pre-allocated capacity. So the higher limit of the capacity is always going to be the length of our numbers array. It's never going to be above that, all right? Because that's going to be the input array. The length of the numbers array is going to be the length of however many items we have inside of that array. So it's always going to be that. So we could say, okay, initially the length is going to be 0, but then the pre-allocated higher capacity is going to be length of the numbers, the input array. So this is what I meant by overcomplicating it. And now we still need to do that loop, and we need to push everything inside of the even numbers. And it looks something like this. So we have our, let me save this. We have our for loop. We have the index, we have the num. We check this num if it is divisible by 2 and produces, if it is divisible by 2, I think that's enough. Then we basically append it to our even numbers. And then what we need to return from this function is going to be that slice as well. Now, let's actually create func main, and this is going to contain our input, which is this array right there. And then we have two outputs. So I'm going to say output 1, which is going to be this. So we're going to say filter. Let me just copy the name. This is 1, and I'm going to pass an input. And let's say 2, output is going to be 2. We need to have 2 print statements. fmt dot print line. Okay, let's pass, and this is going to be, so how do I differentiate between these two? I could say, let me take a look at this. Simple out, I could say simple output, I could say not simple output. You could come up with a better name, right? And I'm going to call this output 2, and this is going to be output 1. We need to specify the type of this. That's going to be integer. And this is no longer that. It needs to be converted into square curly braces. And now that that part is done, let's import fmt and save everything. So there we go. We imported fmt as well. Let's run this. I'm going to clear everything, go run the tab, hit enter, wait a few seconds. And there we go. So we got the simple output 246, not simple output 246 as well. So we are done with the Go version of the solution. Let's go to the Rust version. So in the Rust version, what I want to do is I want to make this as complicated as possible. I'm just kidding. So we're going to go through different cases. So we're going to have actually 5 different approaches. The first approach is going to be the very simple imperative style with manual iteration. The one we did with Go and the one we did with TypeScript. So how do you go about this? We say if and now I'm going to say filter even numbers v1. I'm just going to say v1 up until v5. So we have this numbers array. The type of this is going to be a slice. Now keep in mind, all of these are integers, so I need to type annotate that as i32, but this is going to be a slice of that. And what does this function going to return? Well, this is going to return a new vector that has items with type i32 or integer 32. And the type annotation is incorrect. It should be angle brackets. Very good. So what do I want to do here? Well, first I need to create an array that is going to hold all the all the even numbers. So let's create that. We're going to say let even, again, event, even numbers. This is going to be creating a new vector. There we go. But there is something that we're forgetting here. And that is this even numbers is going to start as an empty list or empty array. But then its population is going to change. It's going to be updated. So it's going to be mutated. It's going to be changed. Therefore, we need to add that mut keyword in order to signify that. So let's iterate over our numbers array. I'm going to say for num in numbers. And in here, I need to check the same thing as I did for the other languages, that number divided by 2 equal to 0. The remainder should be 0. So we're going to say if num modulo 2 produces a remainder of 0, then that means that number is an even number. So therefore, I'm going to grab my even numbers and I'm going to push that number in there. Now keep in mind, there is something else also missing here. So what is missing is, if you take a look at this, we are saying, okay, i32, that's a slice of it. That's a slice. So we're not having access to the actual value. Now this is a slice, so it's like this. So we have an i32, but that's lowercase I. There we go. But what we want is, we want the actual number that has an i32 type. So we want to change this to this. Well, in order to do that, you need to pass in the star sign, which is the dereferencer, or which is the dereference, right? So it's going to dereference the num, and that's going to basically get the actual value for us. And once we get the actual value, we push that value to our even numbers if this operation is successful. If num divided by 2 produces a remainder of 0. We push it to our even numbers, but then what do we return from the function? Well, we return the even numbers. There we go. That part is also done. Let me terminate this statement. Now again, we're going to complete all of these and we're going to run them once, right? So this is it for the first version of the solution. I am going to add a comment here. I'm going to say this is manual iteration. This is the simple one, right? Now let me copy the name of this function. I'm just going to copy the entire function first line, or just function definition, right? There we go. I'm going to come down, paste it there. Because we need this, we're going to say, okay, now we talk about v2. And for v2, we're going to say we want to go with a functional style with iterator chain. And once I write an iterator chain, you're going to see what that is. And you're going to be familiar with it. So what do we want to do here? Well, we want to have some sort of an iterator chain. And what I mean by this is we're going to use Rust's iterator system, which is actually inspired by functional programming. So instead of manually looping, we are going to chain operations together to transform our data. And how do we do that? Well, first we grab our numbers, we say convert it to an iterator so we can iterate over it. And once we iterate over it, what do we want to do in each iteration? We want to check if any number is divisible by 2. So we have this filter method that we can use here. And this is going to accept a closure function, aka an arrow, a callback, aka an anonymous function. And since we're talking about the slice, right? And all the values inside of the slice are references. They're all references. We have not dereferenced anything. We have not added the star or the asterisk. So what we need to do is we need to denote that here as well. And then we check if this is divisible by 2, then we want to select it. Now, before actually being able to collect this into a vector, we need to make sure that all of these references are actual values. So for our array, it's 246, the references. Let's convert 246 to actual values. We're going to do that using the copied method. The copied method is going to do that for us. And since the iterators are lazy in Rust, until you actually call some sort of a consuming adapter, which is collect, which is going to collect all of the values, it's not going to do anything. And there we go. That's it. So this is an iterator chain. We chain all the operations together. That's the second way of solving this challenge. For the third way, we're going to go almost like this, but it's going to be a little bit different. So what is going to be the different part? We're going to say you could still call it functional style with iterator chain, but I'm just going to add on to it explicit copying. Very good. So what I did here was, let me just show it to you. So here I said, okay, I'm going to implement my logic and then I'm going to convert everything. I'm going to dereference everything. Well, I could reverse these two. So I could say first I copy everything. That means I'm dereferencing everything. Then I'm going to do my filter. And in that way, I'm not going to need to do this ampersand. So let me just cut that, put it right here, and then get rid of this. Whoops. And that should be it. We don't have to do anything else. The rest is the same. The next one that I want to talk about is going to be something that we did almost in Go, but what I didn't mention was that the second version of the solution that we did in Go, that was a little bit more performance optimized. But since I talk about 6 items inside of a list or array, there is nothing to talk about performance here. But still, I want to make sure that you know different ways of coming with a solution. So I'm just going to call this, the next approach is going to be pre-allocation. I'm not going to say performance optimized. Pre-allocation, much like what we did in Go, we pre-allocate the length of the array. We do almost the same thing here. So for that, the first part of this function, the function definition, is going to be the same thing. Let's pass that there. It's going to be version 4. So what do we do inside of the function body? Well, we first need to create our array, right? I'm going to say let mut, since this array is going to be updated, we need to say, okay, it is being mutated. Therefore, it's mutable. We're going to call it even numbers. We're going to create a new vector, and we're going to call a method that's called with capacity, with underscore capacity. And what is going to be the capacity? Well, the highest capacity is going to be the length of the numbers array. And we use this with capacity, which is available as an associated function on our vector in order to pre-allocate memory. And the reason that we say numbers dot length, that's, as I talked about in Go, that's, you could call this our worst case scenario, where all of the input numbers, they're all even numbers. So you need to account for that scenario as well, right? So we say, okay, the upper bound of the length of this newly created array is going to be the length of the numbers array, the length of the input array. All right, let's move forward. Well, for our, let me just terminate this before moving forward. We need to have our loop in order to actually iterate over different numbers and check if they are divisible by 2. Now, this is going to look like what we did inside of the first solution, but I want to make this a little bit different. Here you can see we actually dereference these values inside of the for loop. We could do this in the for loop itself, like outside of the for loop, like in the for loop signature itself as well. So we're going to say every one of these is actually references, and we want to dereference them. And where? In any item or any number that's inside of the numbers array. All right, so that what that's going to do is it's going to destructure all of the, again, I need to write this, all of the i32 items into i32. So these are references, and these i32, they're going to be the actual values, the actual numbers. And this is going to do that for us. Now, what that means is we don't have to dereference anything or destructure anything inside of the for loop. So we can just say if num modulo 2 produces a remainder of 0, we're going to select our even numbers, and we're going to push any number that meets that criteria. And that should be it. We need to return something from the function. What is that? That's even numbers. Very good. And for our final solution, what we're going to do is we are going to use all of the type annotations that Rust presumes. So this is not like a good solution to this challenge, but this is just for educational purposes only. So we're going to say this one is going to be functional with explicit type annotations. So let's create our function. I could just copy it from here. First part, there we go. And let me close that. So what do I want to do here? Well, let's first of all, let's create an iterator. I'm going to say iter. What is going to be the type of this iter? Well, we grab that from our standard library, slice and iter. What does this iter accept? This is going to accept items which are of type i32. Where is this iter coming from? It is actually the numbers iterator. So that's the first one. we created the iterator. Next up, I'm going to provide explicit types for our closure. Again, these are just for educational purposes, all right? So we're going to say let filtered underscore iter. We're going to grab our iter, and on it, we're going to call the filter method. And the filter method, as you know, it accepts a closure function. So the closure function is going to have this parameter inside of it. And what this is going to produce is going to be a Boolean, right? The type of the item that this filter method produces is going to be a Boolean. But what is the actual filter method going to do? What is this closure method going to do? It is going to divide something by 2 and check its remainder. Let me terminate that one as well. Terminate this one. So we need to type annotate this num as well. Now, in order to type annotate this num, we need to talk about what this filter method receives. Well, we call this filter method on the iter. What the iter produces for us is going to be a reference, right? So we could say I32, but it is a reference. That's why there is that ampersand in there. So when filter method receives a reference, it passes a reference as well. So what we end up with is double ampersand I32. So this num is actually double ampersand, and the type of this is going to be double ampersand I32. Why? Because one of these comes from the iter, one of these references, the other one is what filter method passes. So that's why I said, okay, I need to type annotate these so you really know how Rust type annotates all of these. After that, we are going to actually convert our references to I32 or integer 32-bit values. So I'm going to say let copied iter underscore iter. This is going to be our filtered iter. Oh, I need to change this to version 5. There we go. So filtered iter dot copied. There we go. And after that, we need to go ahead and we need to collect all of these items, all of these values inside of an array. So let's go ahead and let's do that. So I'm going to say let result, which is going to have a type of vec I32. I'm going to grab my copied iter, and on it, I'm going to say collect. And what is going to be the type of this? This is going to be vec. Let me just pass it there. Vec I32, lowercase I32. There we go. Let's call it and terminate this line. And this is what the function is going to return result. Right. I shouldn't write this return keyword. We don't have it here. So even numbers, there we go. So all 5 are done. The only thing remaining is we need to create our main function. So I'm going to say if in main. And I'm just going to go ahead and get started with our input. So we have our input. Let me specify this. So this is going to be, I could just copy it from here, right? Just copy it, put it right here. This is our input. Terminate this line and let output is equal to filter numbers v1. Let's pass in, it should be a reference to a slice. So I need to pass that in there. Input, this is going to be output 1. And at the bottom, I could write the print statement at the bottom of or at the end of this line, or I could just combine all the outputs and then combine all the print statements. Let's just combine all the outputs and then combine all of the print statements. So for the first one, let's copy the comment. It was manual iteration. Let me paste that here. And then we need to have our either display or debug. I'm just going to pass in the debug specifier here. And this is going to be output 1. Let me terminate this line and this one as well. So let me run these. We have 2, 3, 4, 5. And these should be 5 as well. So 2, 3, 4, 5. The second one, let me just copy. The only thing remaining is these comments and then all of the errors that are going to arise. So it was functional style, and then we have this one with iterator chain. There we go. The fourth one was pre-allocation. Explicit copy. Yeah, pre-allocation. Pass that right here. And finally, we have this functional with explicit type annotations. Save everything. Let's go ahead and let's run it. That's the only way to find out what is wrong here, if there is anything wrong. So Rust CE tab, enter. Okay, so what is it saying? Expected one of these. Collect back. Which line is that? That is line 47. So on line 47, vector I32. Expected one of these. Let result else or an operator instead of these two. Oh, I need to get rid of these parentheses because once I said, okay, I'm collecting all of the values, I type annotated that, and then at the end, I'm calling this collect method. So these parentheses are already on the end. They shouldn't be after the actual keyword. Now let me run this. Oh, it compiled. Very good. I wasn't expecting that. So let's run this, and there we go. Let me go over them one by one. So the first one is our manual iteratrion. That's a typo. I'm going to fix that. We have 246 functional style with iterator chain 246. Functional style with iterator chain, explicit copying, same result, pre-allocation, same result, and then type annotations, same result. There is just a few typos that I need to fix. Type annotations. There we go. That part is done. And where was it? Iterator chain with, oh, here, iteration, manual iteration. Go to the top and put it right there. There we go. So that is it for the solution of this challenge. I hope you enjoyed it. We actually did things a little bit different than our previous challenges. And I tried to keep the solution as simple, but I wanted to give you different ways of actually going and getting the same solution. I hope you enjoyed this. I really enjoyed creating this challenge, and I enjoyed even more teaching it. And I'll see you in challenge number 15.